Hello, good afternoon, everyone. This is Miss Fenton from Lincolnshire, Illinois, Adlai E. Stevenson High School. So just want to start off super fast today with, again, what I mentioned yesterday about the exam. So just so everyone knows, the exam is going to be on Tuesday, May 19th, and you have to look at the time for your area. So if you are in Hawaii, good morning, AP Psychology. You'll be taking it at 8 a.m. And if you're in Eastern time, you'll be at 2 p.m. So that's kind of the later end. The exam this year will consist of 2 questions. Question 1, concept application, and that's going to have 8 tasks. So yesterday at the end of the session, I gave you an 8-task concept application question to practice. So we're going to go over that today. And question 2 is going to be research, right? So it's a research methods question, and it will have 6 tasks. And we'll be giving you practice versions of both of these during these videos. So today we are going to start off by going over that warm-up. We're going to go over yesterday's FRQ, and today is all about operant conditioning. So yesterday you had Siggy the dog. Siggy is a very good dog, and he lives in West Bend, Wisconsin, and his owners have taken him to see a dog trainer to understand his behaviors. They wonder, why does he get excited when he hears car ride, and why does he whine when he sees suitcases? Siggy has learned that when his owners say treat, that food is coming, and he begins to salivate at the word treat. Siggy's also a really good guard dog, and he chases anyone who passes the house, including the postal carrier, from behind the fence in his yard. So for part A, for the application, you're going to talk about how a dog trainer would explain Siggy's behavior, so Siggy the dog. In part B, you're going to use these same concepts, but you're going to talk about the owners interacting with their dog. So let's take a look at these point by point. So the first point is unconditioned response. So in classical conditioning, an unconditioned response, or UR, is an involuntary reaction to an unconditioned stimulus. And remember, whenever you see unconditioned, you mean unlearned, right? So you want to say that it's an involuntary reaction or it's a reflex. So the trainer, in this case, would explain that Siggy salivates because it's an unlearned reflexive response to food, which is the unconditioned stimulus. So in this case, you see I put a little space between the definition and the application. That definition, short and sweet, it's one sentence. And the point of it is to make sure that everything that's an important part of a definition is also in that application. So you're going to see what's underlined in the first part is going to be underlined in the application. And again, you don't have to write a definition. You can just do the application, but your application must have all pieces of that definition in order to score. So in this case, the trainer is going to explain that Siggy's unconditioned response, right? It's what's going to later help him develop a learned salivation response to the word treat. So you won't have to go through the entire process of classical conditioning. You do have to talk about the unconditioned response, and you're probably not going to be able to apply it or define it without also talking about this unconditioned stimulus. Now, as a note, you could do, instead of the salivation as an unlearned reflexive response, you could replace that with Siggy's whining, right, as an unlearned reaction to the owners leaving. So what you can't use, however, is Siggy running or chasing in the yard, because those are voluntary actions. So let's take a look at the next point. Next point is the conditioned response. So in classical conditioning, condition means learned. So it's a learned and it's classical, so it's an involuntary. And you want a synonym for response, so maybe reaction, to a conditioned stimulus. So again, if you use the example of Siggy running or chasing the postal carrier, it's going to be incorrect because running and chasing are not involuntary. Now, if you said he was excited and his heart started racing, when he saw or he was afraid when he saw the postal carrier, so if you use an emotion or an involuntary physiological response, then that would be okay. So again, here I have underlined the key part. So here you have to have a learned involuntary reaction. So versus an unconditioned response where it's unlearned. And you have to have that response, right? So in this case, the trainer is going to talk about salivation to the word treat, and treat is that conditioned stimulus. So, and again, you could also go with Siggy whining to his owners leaving as an unconditioned response of like the dog being sad, right? Emotion. Okay, next up, stimulus discrimination. So in classical conditioning, this means the animal is going to demonstrate that learned involuntary response, that conditioned response, only to the conditioned stimulus and not any other similar stimuli. So with Siggy, the trainer might say, because remember you have to bring up the trainer and you have to talk about Siggy, that Siggy demonstrates discrimination because he whines, that's the involuntary piece, to only large suitcases, the conditioned stimulus, and not similar items, right? So not gym bags or travel suitcases. So you need to have both only the conditioned stimulus and not the similar stimuli. And you could do the same thing with treat. So if you went with only to the word treat as your conditioned stimulus for discrimination, then it would be not to similar words like maybe cookie, I don't know, bone or whatever things you might give your dog. Okay, spontaneous recovery. In classical conditioning, this is the reappearance of an extinguished conditioned response without retraining. So if it's relearning, that's different. That's Pavlov bringing out the meat powder and the bell together again. So according to the trainer, Siggy no longer whines when he sees the large suitcases. There's your extinction. However, one day this extinguished whining, right, to the suitcase reappears without training. So spontaneous, just without warning, without retraining, it just comes back again. And you could also, again, do spontaneous recovery of salivation to the word treat after that had become extinct as well. Okay, so the next part B, is about Siggy's owners interacting with their dog. And I use some terms from other units. So when you get a concept application question, typically on the AP exam, it's not all from one unit. Now, I certainly can't guarantee that there wouldn't be one all from one unit, but I've not ever seen that. So just trying to give you some practice and also to review across earlier units that we've covered. So feature detectors, these are specialized neurons, right? So they have to be in the brain. So where students might go wrong here is mentioning feature detectors in terms of like the eye or the retina. So these are definitely neurons and they're in the brain. So you're going to want those key pieces from that definition, that they're neurons, right? That they respond and that they respond to components of an image. Now you could also, there's also feature detectors for more sophisticated stimuli. So there are feature detector cells for things like faces. So if you wrote, Siggy's owners were able to recognize the face of their adorable dog Siggy because brain cells, which is another way of saying neurons, that are specialized to respond to faces provide that information. So you could also do feature detector cells for faces, which are not in my definition here. Next one is the cocktail party effect. And this is another one of those terms, kind of like yesterday with learned helplessness, where sometimes the definition helps to center you because the definition is pretty complex. So with the cocktail party effect, it's this idea that you can focus your attention on one conversation and ignore all the background, right? So you're at a high school dance, you're at homecoming, and it's really loud, right? The DJ is really loud. There's a lot of conversations happening around you, but you can focus your attention on the conversation that you're having with your friend, right? But some unintended messages are actually being processed. So if somebody were to call your name, you would maybe hear that, right? So your name is kind of a typical example that you would see with the cocktail party effect, but it could also be any other kind of really important information. So Siggy's owners are having a focused conversation outside, and they can listen to each other and ignore all the neighborhood noises. But when the neighbor screams Siggy's name, that grabbed their attention. So this is an example that has all those pieces, the focus on one conversation, ignoring the outside noises, but yet still attending to that important information. So cocktail party effect is like a complex term, right? We're going to follow that up with hippocampus, which is pretty straightforward, right? So the hippocampus, it's in the limbic system. I don't think you'd have to say limbic system per se to score, but it's a brain structure, so you definitely want it in the brain, related to encoding new long-term memories. So Siggy's owners form a new long-term memory, or a new memory would be fine, of the first time Siggy sits on command because their hippocampus encodes it. Now, what you can't do is you can't have memory retrieval, right? Or they remember this one time, you know, in the past when Siggy did something, because memory retrieval and storage, that's not really linked to the hippocampus. Next term is absolute threshold from sensation and perception. And here, this is about the minimum amount of stimulation a person or a dog needs to detect a stimulus at least 50% of the time. So you have to be careful here. It's the minimum amount to detect something, because if you use a couple different words, like you could veer into difference threshold, right? It's very similar sounding, but that's the minimum amount of change, right? That's difference that you could sense 50% of the time. So here's a potential example. So you're going to want to get detect. You're going to want to get that 50% of the time in there. This is a pretty elaborate one because I have both, Siggy detecting something and the owner. But Siggy can hear his owner's truck even a block away, and he runs to the door, right? Which is an operant response, but maybe he's classically conditioned as well. His little heart is racing, he's happy. His other owner, who's at home, cannot hear the truck, can't detect it from as far away as Siggy can, because it does not cross his absolute threshold, meaning that he could not detect or hear that sound at least 50% of the time. However, good news is he's going to know the truck is arriving because Siggy let him know. So that was an 8-term FRQ, and hopefully you were able to practice doing all of those in a row. And hopefully you spaced out your answer. You want to answer those points in order. If you skip around, it's really easy to say, take a term like hippocampus and accidentally apply it to the trainer when it's supposed to go with the owners. So you really want to keep that order. If you do define, you want a short, sweet little definition. And then the point of that is to make sure all aspects of that potentially complicated concept like cocktail party effect end up in your application. So again, apply, 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 double check, make sure you use synonyms if they were needed, and keep practicing with that time. So again, I always want to emphasize that the score is about the application, but the definition's there to help you. Okay, let's get started. Let's talk about operant conditioning. Yesterday we talked about classical, now we're going to talk about operant. So again, quick reminder, anytime you see conditioning, it just means learning. And anytime you see cognition, it means thinking. And conditioning, again, is a relatively permanent change in behavior due to experience. Operant conditioning is a process in which voluntary responses are learned as a result of their consequences. And consequences in this case are going to be reinforcements and punishments. So our exam tip here, remember, operant conditioning, voluntary responses, classical, involuntary. So with Pavlov, the dog is salivating, that's an involuntary reflex. With Skinner, the mouse is pushing a lever, that's a voluntary response. So operant conditioning actually has its roots in instrumental learning, which was created by Edward Thorndike. So Edward Thorndike's research is kind of the building blocks that you're going to see with Skinner. And he studied something called instrumental learning, which is conditioning that explains how animals and people learn voluntary behaviors. And it's the basis for operant conditioning. His law of effect, okay, so he discovered this by studying cats, and he put a hungry cat in a puzzle box, and the cat had to learn, right, how to escape. And what he did, if you look at that kind of graph of the successive trials in the puzzle box, so the cat would find its way out, he'd put the cat back in. So over time, over successive trials, the cat was able to escape faster because the cat was kind of streamlining its responses. So at first it tried some things, and what happens is like certain behaviors that the cat acted on, like pushing the lever with its paw, led to its release. Those behaviors would be repeated. Behaviors that weren't successful would not be repeated. So you have Thorndike, and he has the puzzle box, and he's studying cats. And then you have Skinner. And Skinner studied operant conditioning, and he really dramatically expanded upon the law of effect and instrumental learning. But it did still involve a voluntary action on the behalf of the learner, right? So to Skinner, we operate on our environment, and we operate based on experience of previous consequences. So if a behavior in the past was reinforced, we're going to be more likely to repeat it. If previous behavior was punished, less likely to repeat it. And Skinner had a little bit more sophisticated device than the catch puzzle box. He had what was called an operant chamber, except everybody calls it a Skinner box. So a Skinner box is kind of a really high-end version of a puzzle box. It has a lot more bells and whistles. It's an animal cage that Skinner created to test operant behavior, voluntary behavior. And this one is for a rat, but he also had operant chambers for a pigeon. Now, what it has to include is, in this case, the rat has a lever, and it can be set up where if the rat presses the lever, it receives a piece of food, right? A treat from the food dispenser. If it could be also conditioned where pushing the lever on the bar, it only results in food if the light is first turned on, right? So the rat can learn that. Could also study punishment, because potentially if the rat pushed the lever, it could result in a punishment for the rat, maybe like a really loud noise from the speaker. In which case the rat would be less likely to repeat pushing that bar because he was punished. So this is it's a more sophisticated tool than Thorndike. It also had something called a cumulative recorder to collect data. And it made operant conditioning, that apparatus, like more precise and more sophisticated than Thorndike's original puzzle box. Now, with reinforcers, there's two kind of broad categories. So anything that's a reinforcement or a reinforcer, if it follows a voluntary behavior, it's going to help that behavior increase in the future. And Skinner and other behaviorists, they talk about primary reinforcers, ones that are naturally rewarding. The mouse does not need to learn to value food or warmth. When you see something like the removal of pain or discomfort, you're going to see that when we talk about negative reinforcement. So that's also a reinforcer, the removal of pain. A secondary reinforcer has to be learned. So money, attention, praise, the removal of ridicule or exclusion, that has to be learned. So money is essentially green pieces of paper. So you have to learn that money has value. It's not innately or naturally reinforcing. Okay, so again, I'm going to just go really slow through the operant conditioning definition. So this is the process in which voluntary responses are learned as a result of the consequences, what happens after reinforcements and punishments. And when you're writing an example for an FRQ, you're going to want to make sure you include this entire process, right? So for example, if you have a stimulus in the form of the light turning on in the Skinner box, and the mouse pushes the lever, which eventually the mouse is going to push the lever, right? It's just going to wander around. It's kind of a mouse-like behavior to do. And as a consequence, something's going to happen, right? So if the mouse, as a consequence, receives a reinforcement, receives some food, in the future, you're going to see that that mouse will then increase. Now, if the light goes on, the mouse pushes the lever, and as a consequence, the mouse receives like a loud noise from the speaker, a punishment, the mouse is going to be less likely to push that lever in the future. So with operant conditioning, you want to think about it in terms of a stimulus, a voluntary behavior by the person or the mouse or the pigeon, and then a reinforcement. Then you want to make sure on that FRQ that you indicate that that behavior increases in the future, that same voluntary behavior. If it's a punishment as a consequence, it's going to decrease in the future. Skinner also talked about timing in the same way that Pavlov studied timing with classical conditioning. And he found that basically it works better if that consequence comes sooner, like immediately for the mouse. Even with people, immediate reinforcers and punishments have more effect on future behavior than delayed ones. So, big thing that you want to notice here, again, operant conditioning, if you've been reinforced, and it works, right? Operant conditioning, you learned that voluntary behavior will increase. If it's a punishment, the behavior is going to decrease. And that's kind of a huge piece for separating these four types of consequences. So let's start with reinforcement. And again, as I mentioned, these are consequences that follow that voluntary behavior that can either be added in the case of a positive reinforcement or subtracted, right? But either way, whether it's a positive or a negative reinforcement, that behavior is going to increase. So it's going to make that behavior occur more in the future. So if you take something like a stimulus, so your teacher asks a question and a student raises their hand, teacher calls on them, they give a comment or a contribution to the class, and let's say as a consequence, the teacher gives them a $10 bill. So in the future, The teacher asks a question, the stimulus comes back again. Is that student going to raise their hand again? Yes. If they do, that's a positive reinforcer. It worked. The behavior increased. Now, you might, in that scenario, if raising your hand resulted in a $10 bill, you might find that the other classmates in the room who did not raise their hand and received the initial $10 might also start hand-raising behavior. And that would not be operant conditioning, that'd be social learning, observational learning. Negative reinforcement, again, this is a subtraction. It's not, positive doesn't mean like smiley face, and negative doesn't mean sad. It just means subtracting. So now you have a stimulus, you have a voluntary behavior, a consequence, and that behavior is going to have to increase. So in the case of a negative reinforcement, you could take the example of a headache. So that's your stimulus. A person has a headache. Voluntary behavior, maybe they take a pain reliever. And as a consequence, you have a subtraction, a minus, right, of a headache. That's a negative reinforcement if the next time when they have a headache, they also take a pain reliever. So you have stimulus, voluntary behavior, consequence, future behavior. If it's a reinforcement, it's going to increase. So it could be your parents tell you to clean your room, you voluntary behavior, clean your room, and they say, well, as a consequence, you don't have to do the dishes. So in the future, when you're asked to clean your room, you do so. Now, punishment, you have both positive and a negative. And again, it's addition and subtraction. It's not about, happy or sad. So with a positive punishment, you're going to add something. You're going to present something to the organism after the voluntary behavior that decreases that behavior in the future. If it's subtraction, if it's negative punishment, you're going to take something away that's also going to make that behavior less likely to occur in the future. So sometimes a negative punishment, like a common example is a timeout, right? So with a positive punishment, if it was stimulus, you had a headache, voluntary behavior, you took an aspirin, and then let's say as a consequence, it made you nauseous, it made you feel bad, right? So that's a positive punishment. In the future, when you have a headache, you're less likely to take a pain reliever because it didn't work out. So a positive punishment, so for example, if Aaron is an imaginary person, fumbled the ball and his coach makes him run 10 extra sprints, and he hates this, right? So the addition of sprints, which he dislikes, is a positive punishment. So in the future, he's going to fumble less frequently. If it was a negative punishment, it might be, there's a football game, that's a stimulus, and Aaron fumbles the ball during, maybe it's practice, fumbles the ball, and as a consequence, the coach says he cannot start in the next game. He's going to lose subtraction of his starting position. So in the future, again, he's going to fumble less frequently. So when you're looking at an operant conditioning example, like if you're reading a prompt and it includes operant conditioning, the easiest way to do this is to underline the voluntary behavior. Do that first. If the behavior is actually involuntary, it's not an example. So something's wrong, you're looking at something that's classical potentially. Next, determine if it's reinforcement or punishment. If the behavior increases, just write capital R, it's a reinforcement. Don't worry about positive and negative yet. If the behavior decreases, write like a capital P and don't worry about positive or negative. Once you figure that out, if it's a reinforcement or a punishment, that's where you're going to start. Now, if the behavior is not influenced, the example that you wrote, like if it doesn't either increase or decrease in the future, your example is incomplete. And then figure out, is it positive? Was something added or was something subtracted? Is it negative? So check for understanding. Again, for the following examples, underline the voluntary behavior. Then figure out first, is it a reinforcement, increase in behavior, punishment, decrease, or if it's none, in which case you can stop there because you have to fix something else, then figure out whether or not it was positive or negative. So here's your first example. Marisol eats Thai food for the first time and it is delicious. She decides to begin eating Thai food more often for that delicious tasting food. Number 2, 9-year-old Nina keeps slamming the door to her room. One day, when Nina came home from school, she realized her dad had removed the door from her bedroom. After the door was returned, 2 weeks later, Nina never slammed her door again. So starting with the first example, I'll give you a second to underline the voluntary behavior, decide if it increased, reinforcement, or decreased, right? So you're underlining the behavior, that's eating, right? That's the behavior. Does eating increase? If so, write reinforcement. If eating decreases of Thai food, then you'd write P for punishment. Then decide what happened here, right? Was it addition of something that made her repeat the behavior or subtraction? So hopefully you picked positive reinforcement. Her behavior of eating Thai food increases in the future because with the addition of delicious tasting food. Example number 2, here you have the behavior again, which is slamming the door to her room. That's the voluntary behavior. And what's the consequence? How we're going to figure that out is, first of all, does the behavior increase or decrease? And then was something added or something subtracted? So her behavior of door slamming decreased, so you should have it as a punishment, and you should have negative. It's minus a door. So something was taken away, and that decreased her door slamming behavior in the future. Next example, 2-year-old Trixie says a bad word at dinner and her parents scold her, but spend the rest of the meal paying attention to Trixie. Later, Trixie repeats the bad word. Number 4, Terrence bought his girlfriend flowers and she gave him a kiss. Number 5, Savannah hates spiders and finds a spider in her room and screams. When she screams, her father comes into her room and kills the spider. The next time Savannah sees a spider, she screams. So I'm going to pause here just briefly, but you can certainly pause the video, think about the voluntary behavior, then determine if it increases or decreases, and finally, is it about an addition or a subtraction? So for the first one, you have a positive reinforcement. So although her parents scold her, they also pay attention to her, which seemed to matter apparently more to Trixie. If Trixie's behavior of saying the bad word increases, she's been reinforced. And what she received as a reinforcement was the addition of attention. So it's more about outcome than intention. So you may want to punish someone by yelling, right? But if they are complaining, but if they think that's humorous for some reason, sibling, then maybe they would repeat the behavior, right? So if my brother, when we were kids, would poke me in the car and I would yell, right? Thinking that in my intention might have been to punish him so he wouldn't do it. But if he keeps doing it, if he keeps poking me in the shoulder, because watching me, scream or react was reinforcing to him, that was a reinforcement. Number 4, this is a non-example. So it's a good start. He bought his girlfriend flowers and she gave him a kiss. So in order for it to be a positive reinforcement, he'd have to buy her more flowers again in the future. And while that may be true, it's not listed here. So an example, if you were writing an FRQ, it would be a bit incomplete. So Savannah's behavior is screaming, and that behavior increases, so it's a reinforcement. And in this case, it's negative, it's subtraction of a spider. So for your own practice, I would strongly recommend pick a scenario and create an example of each of the 4 consequences, right? Create your own application. Write out the whole thing and then double check to make sure that you have all those pieces. You have the behavior increasing or decreasing. You've clearly indicated the addition or the subtraction and why it's positive or negative. So again, this is that formula for success. You want to have a stimulus, a voluntary behavior, a consequence, and a future behavior. Okay, so these 2 terms is when we're talking about the consequences in operant conditioning, usually this is where mistakes happen. Negative reinforcement versus positive punishment. And a lot of this has to do with the fact that we don't think of punishment as positive, right? That feels strange. But remember, this is addition. Now, negative reinforcement, that behavior is going to increase. If it's punishment, even though it says positive, it's going to be a decrease in that behavior. And both negative reinforcements and positive punishment involve this idea of aversive stimuli. So you might see that word in a prompt. An aversive is something in the environment, a stimuli that's bad or undesirable in some way. In a negative reinforcement, what that involves is the organism escaping or avoiding that aversive stimuli. With positive punishment, it's the addition, right? That's positive again, of the aversive stimuli. With negative reinforcement, it's the subtraction of aversive stimuli by escaping or avoiding. So you might see these terms as well with escape and avoidance conditioning. With escape conditioning, it's a voluntary behavior that causes an aversive stimulus to stop, right? And you learn this, and so you repeat that behavior in the future. So if you are a runner and you run really long distances, or you go for really, really long, bike rides, you might find that after you're done running that you might feel a bit dehydrated and maybe have a little bit of a headache. And you decide, you've learned that if you drink Gatorade or drink water, that headache goes away, right? So you have learned to escape the headache essentially by the voluntary behavior of drinking like the sport drink, right? So that's escape conditioning. With avoidance conditioning, it's kind of like a preemptive strike, right? It's a voluntary behavior that prevents that aversive stimulus from even showing up in the first place. So now before you go on that really long run, you drink the sports drink ahead of time so that the headache or the dehydration that could occur from running or being in the heat doesn't occur in the first place. So with escape, right, you might clean your room to escape kind of the nagging or the repetitive requests from your parents to clean your room. With avoidance, it might be, maybe you pay your bill for your cell phone early so that you never end up with a late fee. Another term that kind of goes with operant conditioning is this idea of discriminative stimuli. So this is a particular stimulus that indicates if a voluntary behavior, like if you do something, if it will work or not, right? So on a very simple level, Skinner could teach a pigeon to peck the key in the operant chamber if it saw a blue light, but not if it saw, say, a green light or a red light, right? So that stimuli signal to the pigeon when that behavior would actually work, right? And you can actually teach, as you see here in this example, pigeons some pretty complex behaviors. And Skinner did a lot of interesting stuff with pigeons too. You can look into that. Taught them to play ping pong, even had kind of pigeon guided missiles was kind of a idea he had. But pigeons can become really, really skilled at certain things. And most people don't want, very serious medical tests to be determined by pigeon. But other animals, if you see here, they've been trained to like sniff out landmines or find people amid, rubble, like collapsed buildings. So discriminative stimuli for animal learning. Now, in real life, you also experience discriminative stimuli. So if you've ever seen your parent or a teacher make the gesture, that is a discriminative stimuli that's telling you that talking behavior will not be reinforced. You have also maybe learned, right? So discriminative stimuli, you've learned that if you're tardy to teacher A's class, that's probably going to result in a negative outcome for you, maybe a detention, right? But in teacher B's class, nothing's really going to happen. So that's going to affect your behavior of whether or not you go to one class on time, potentially, versus another. So Skinner also worked with this idea of shaping. So if you want to create a new voluntary response that's a little bit more sophisticated, especially if it's something that's more unusual for the animal, what you need to do is provide reinforcements for successively closer approximations. So if you want to teach Siggy here to sit up and shake hands with his paw, he's a dog, so you can't actually ask him to do that. So you want to reinforce in some way successively closer. So maybe at first, in order for him to do it, you have to kind of like pick up his paw. But eventually, you won't have to give him as much help, and he'll be able to do it on his own. So successively closer approximations until the correct behavior is displayed, and then you would only reinforce for the full correct behavior. Now, what kind of reinforcements should you use? Would you use primary reinforcements to teach Siggy a trick, maybe food? Or would it be better to use praise? Good doggy. Okay, another kind of serious, like broad area. And what I love about operant conditioning is just the whole like puzzle of it all, like the positive and the negative, like you have to pick figure out both whether it's reinforcement or punishment, and then positive or negative. And you're going to see that with these intermittent schedules of reinforcement, you're going to see similar kind of thought process. So Skinner looked at two things. If you continuously reinforce, every time that mouse presses that lever, it receives a treat. If you do this, every time a student raises their hand, they get $5. Learning is going to happen fast, but the learning is fragile, I guess. It's vulnerable to extinction. So if you suddenly stop, right, reinforcing, so the mouse starts pressing the lever and no treats appear, learning goes away quickly. So you have really fast extinction rate if you use continuous reinforcement. So on one hand, they learn quickly, but on the other hand, rapid extinction. So what Skinner devised was a series of intermittent or partial reinforcement schedules. Now it does take the animal. So in the case of an operant chamber, a Skinner box, learning is going to be slower, but that learning is more resistant to extinction. And there's 4 broad areas. So you have 2 ratio schedules and 2 interval schedules. And each of these ones can either be fixed or variable. And if you want to just define those individual words, if you see fixed, it just means predictable. So you can see that here in this chart. If it's variable, it's unpredictable. So when it says every nth behavior, so every 10 coffees, get 1 free, that's a fixed, a predictable amount of behavior. Or it could be ratio versus interval. With ratio, the reinforcement is going to occur after every so many correct behaviors. So if it's a fixed ratio, it'll be a defined kind of predictable number of behaviors you have to do in order to get the reward. If it's variable, it's an unpredictable number of behaviors. With interval, it's about time has to pass. So it's the correct response that occurs after either a set, predictable amount of time, or an unpredictable, so fixed or variable, has passed. So think of intervals as like clocks, calendars, something about time. So let's take a look at the ratio schedules and give you a few examples. So with a fixed ratio, there's a predictable number of correct behaviors. So for example, like we had on the previous page, buy 5 coffees, get 1 free. So maybe you've had one of those little cards that certain restaurants might give out. So if you accumulate 5 stickers or 5 punches for purchasing coffee, your 6th one is free. And what's nice about these is the more the subject responds, the faster they get their reinforcement. So if you're a mouse in a Skinner box and you have to press the lever 5 times for a mouse treat, the mouse is going to press really quickly. 1, 2, 3, 4, 5, eat a treat. 1, 2, 3, 4, 5, eat a treat. If you really want that free coffee, you're going to be more likely to purchase more, right? That's why they use those devices. Now, with a fixed ratio, you also want to keep that ratio reasonably small. So it wouldn't be very successful if you had a card that people had to carry around, buy 40 coffees, get 1 free. People probably give up on your card. With variable ratio, again, you still have to do the behavior in order to get the reinforcement, but it's unpredictable. It's variable how many before you receive the reinforcement. So the mouse might press the lever 5 times and get a treat. Then the next time, maybe it takes 3 times, then maybe 12 times, then 7. So what happens is the mouse has no idea when it's going to work. So you have kind of this consistent, steady response. And variable ratio is often called the gambler's schedule because any type of gambling and any type of sales is going to be an example of a variable ratio schedule. And that reinforcement in sales is money. It's the actual sale. So sometimes a salesperson might have to approach 5 people and give a sales presentation before they make a sale. Then they might have to do 3 and they'd get a sale, and then 10 and then 2, and they might get 2 in a row. So they never know, and that creates this consistent behavior that's resistant to extinction. With the interval schedules, you have time has to pass. With a fixed interval, it's the correct response after a set or predictable amount of time. And that time in terms of minutes or days. So a salaried employee that receives a check, that's the reinforcement, every week, like every Friday or every 2 weeks. Students who are rewarded for a good grade on a test, if it's a predictable test, right? So if a teacher offers a test. They're going to say there's going to be a quiz every Thursday. Every Thursday, we're going to have a quiz at the beginning of class. Assuming like you want that good grade, you want that reinforcement, studying behavior is what the teacher's trying to reinforce. So if it's a test every Thursday, when will many students study? If it's every Thursday, maybe Wednesday night, yikes, maybe Thursday morning. So, and then after that test or quiz on Thursday, studying behavior is going to kind of go away for a while. Well, the same thing kind of happens with a mouse. So if you set a mouse on a fixed interval schedule where every 10 minutes pressing the lever will result in food, but anytime during that interval between, pressing the lever has no effect. So what the mouse will do is just kind of hang out. They can't tell time exactly, but when it gets close to that interval, right, that 10-minute mark, say, then it'll be some pressing. And then as soon as they get the treat, they're going to stop because they know it's not going to work again for a period of time. So it's similar with studying. When you're going to study really close to that interval end, so like Wednesday night, and then you're going to stop for a while and maybe do work for other classes. Variable interval, your classic example is like fishing. But if you're looking at it in the case of like a test, right, studying behavior as a reinforcement, the voluntary behavior is studying, the reinforcement would be the good grade on the test. This would be like a surprise quiz, a pop quiz. So now if you want that reinforcement, you want that good quiz grade, and you have no idea which day the teacher's going to present that quiz, now you're going to be probably more likely to have a steady studying pattern because you don't know when that interval is going to show up. So here's a little exam tip about interval. So these are any response made during the interval period are not reinforced. Okay, for our check for understanding here, we're going to do a little bit with graphs. So if you look at example 1, which schedule produces the highest response rates, ratio or interval? Which schedule produces the highest, steadiest rate or response with no pauses? And which schedule produces a low response rate except just before the reinforcement is delivered? So now you can do this just from the graph or from your knowledge of the concepts. So we're going to pick up the pace here a little bit, but which example? You can see here in example 1 by looking at the response rate, which is on the y-axis, that variable schedules are more resistant to extinction. With number 2, which schedule produces higher rates of responses? On the y-axis is responses. That is going to be ratio schedules. So you can see them on the left side, how many more responses they have than the slower curve of the interval option. Which schedule produces the highest, steadiest rate with no pauses? That's variable ratio. So that's that gambler's schedule. And you see the diagonal lines here represent the reinforcement. So which schedule produces a low response rate except just before the reinforcement? That's that fixed interval. When you're going to study right before that announced every Thursday quiz. And what that does is it creates the scallops that you see on the graph in the fixed interval. Premack's principle, this is just an additional term, right? So it's an idea of using a behavior that's preferred to increase a behavior that's less preferred. So if you want your children to eat vegetables, that's the desired behavior, you make a rule that vegetables have to be consumed before they can play video games, which is their preferred behavior. If you don't like studying as much as you like maybe listening to music, then what you could do is say, I'm going to study for 20 minutes and then I'm going to watch a John Legend video. And then I'm going to study for 20 minutes and I'm going to watch another music video. So you're going to reward your less desired behavior with the desired behavior. Okay, just a quick debrief and some tips. So again, conditioning is learning. Classical conditioning, you need reflexes or emotions, and the responses are going to be the same or similar if you remember from yesterday. In classical conditioning, that neutral stimulus and conditioned stimulus are going to be exactly the same if learning occurs. You're going to have these same phenomena in both classical and operant conditioning. Operant conditioning, the responses have to be voluntary, and you want to make sure that you separate this idea of reinforcement, increasing behaviors, and punishments, decreasing behaviors. Also, make sure you review. You can go back and like rewatch that section, maybe go a little bit slower on the partial or intermittent schedules of reinforcement. This is just a little review slide. I would suggest pausing, maybe testing yourself on this. Really separate these two types of learning. Okay, this is your exam practice for Monday. So hope you have a great weekend, but here is an 8-point concept application. And it's going to include mostly terms from learning, right? So mostly terms from today, but also some terms at the bottom. You're going to see something from the biological basis of behavior and also from sensation and perception. So I hope you have a really great weekend, and we will see you again Monday with the answer to this FRQ, and we're going to move on to cognition, thinking, and memory. Thanks for watching, and we hope to see you soon. Be sure to take the practice question. Bye-bye.